All right, here we want to find the sum of this infinite series, as the sum, as n goes from 1 to infinity, of 4 times 1/3 to the n minus 1 power. Okay, so as an infinite series, right, the key is we see that this, it starts at 1, right, the index starts at 1, but then it goes all the way to infinity, right? And the key is, look at the common ratio here, right? This is going to be the common ratio. The common ratio here is 1/3. If you think about it, each successive term is being multiplied by 1/3. So actually, these terms, right, these terms are getting smaller and smaller as we keep moving along the sequence here. Okay, so as an infinite sequence with a ratio less than 1, right, there's actually a formula for this to find the sum, right? The sum, notice I don't put a subscript of n here. Okay, so the sum of an infinite series when r is a fraction less than 1, okay, is a1 divided by 1 minus r. Okay, so to find the sum of an infinite series, okay, and remember we can only find the sum when the absolute value of r is less than 1. Okay, so we need the first term and we need r. Well, we know what r is, right? R is equal to 1/3. So to find the first term, we just have to plug in 1 into the series, right? So 4 times 1/3 to the, well, in this case, we just get 0, right? So the first term is going to be 4 here. All right, so let's plug everything in, right? We're going to get 4 divided by 1 minus 1/3. And check out what happens here, right? This is 1 minus 1/3 is 2/3. We get 4 divided by 2/3, which we can rewrite as 4 times 3 over 2. Well, 4 times 3 is 12. 12 divided by 2 is actually equal to 6. Think about what this is saying, right? If we take this infinite series, okay, the sum of all the numbers is actually going to equal 6. Okay, and this actually happens quite a bit when we're talking about infinite series. And this is a neat little property here. Okay, so in this case, even though this is an infinite series, okay, the sum is equal to 6.